Hello, my dear lovely students. How are you? I hope you are quite well and your study is going very fine. This is lecture number 14 of aldehyde chapter, and this is the chemical properties of aldehydes and ketones. We are going to understand here the how the alkyne react with the carbonyl compound. This is the nucleophilic addition of alkynes. And second, we will understand that how Grignard agent will react with the carbonyl compounds. And third, in the last video lecture, which I have uploaded in the channels, the detailed video of Grignard reagents, how the Grignard reagent will react, what the mechanism is, almost all the functional groups, how react with the Grignard reagents, that all the things I have out there. So you have a doubt, please you go and see that. I hope after that you will not have not a single doubt regarding the Grignard reagents. So, but the two lectures, two reactions we understand here. And along with that, one reaction which I forgot to mention in the last video lecture in the Grignard agents, this is the synthesis of ketones, that how Grignard agents will react with the nitrile compound. In the NCERT, this is given as a method of preparations of ketones. So that reactions also we understand here through mechanisms. Okay, so let's start here. Students, see that the first is that what I am going to write here, addition of alkynes. Addition of alkyne is that nucleophilic additions. What? This is the nucleophilic additions. So which alkyne is going to be reactive, students? Which alkyne will react with the carbonyl compound? Usually terminal alkynes, because terminal alkynes contains acidic hydrogens. What alkynes? This is the terminal alkynes. Okay, because terminal alkynes contains acidic hydrogens, right? See here, this is CH3, C triple bond CH. So this H is the what? It is acidic hydrogens. Correct? Now next is that this acidic hydrogens, and similarly one more examples here, HC triple bond CH. How many acidic hydrogens? You have two acidic hydrogens. So this type of acidic hydrogens which will react with the base and generate a good nucleophile. So that nucleophile attack on the carbonyl compounds. What base we will use to attack on the alkynes? Because as you know, alkyne is a highly acidic substances. So RO negative, this is the alkoxide ions, which is a stronger base, and NH2 negative, which is also the amide. Both are the stronger base. Both base you can take to remove the hydrogens from the alkynes. So let's see that to the example here. Suppose we have the CH3, C triple bond CH, and we have taken that NH2 negative base, which will attack on the acidic hydrogens. And what happens? Ammonia is going to be removed here, and then CH3, C triple bond C negative will form. Now this nucleophile is going to attack on the CH3, C double bond H, and what happen? Here it will attack, it will remove here, and then that the CH3, C O negative H, C triple bond C, CH3 will form. And do the hydrolysis here, then CH3, C OH, H, C triple bond C, CH3 will form. Okay. So, okay, one more example here, students. Suppose we have a HC double bond H we have taken, formaldehyde, and HC triple bond CH, alkynes which contains the two acidic hydrogens. So first what happen? NH2 will react, NH2 negative, that will form the ammonia. So one side will generate the nucleophile, C triple bond CH. Here's nucleophile is generated, which will react with the formaldehyde. And now what is going to be happen here? That things will happen. H, C, H, O negative, C triple bond CH. Now do the hydrolysis here. So H, C, OH, H, C triple bond CH. Again, still you have the one acidic hydrogen which will react with the NH2 negative. So in that case, what is going to be happen? OH, H, C triple bond C negative generate. That is going to be react with the formaldehyde. one, because we have taken the 2 moles formaldehyde, correct now? So 1 moles formaldehyde is still left. It will attack here, and that will generate here like that, HCO negative, H C triple bond C, and COH, H and H will form, which is going to be the hydrolysis here. So HCOH, HC triple bond C, COH, H and H will form. So these things is that the resultant of addition of alkynes to that the carbonyl compound. This whole process is called, students, the process is called what? Ethynylations, or this is called ethynylation process, because we have taken the ethyne group like that. So these things, if you take the propyne, this is called propanylations. If you take the butane, this is called butanalations. Okay. So we have taken that ethyne. So we have this is called ethynylation. Similarly, you can say that propanylations. Okay. Okay. Students, now next is that the carbonyl compound will react with that. Next is that RMGX when react with the formaldehyde. See that the formaldehyde, as you know, grenadine act as a nucleophile here. So bond will break, and what is going to form here? That will attack here. Its whole part is a positive, so it will attack here, and that will form the HCO MgX, H and R, and then after hydrolysis, then what is going to form? HCOH, HR, that is the 1 degree alcohol, correct? Similarly, if we take that R dash MgX with the acetaldehyde, so what things is going to be happen? That will attack here, and it will form the CH3CO negative, H R dash. After hydrolysis, what happened? That the form the CH3COH R dash H will form the 2 degree alcohol. Similarly, when we take that R dash MgX CH3 C double bond OCH3, so that will attack here. It will remove, and then CH3 CO negative MgX, and here is that CH3 R dash, and when the water is taken, then form the CH3C OH CH3 R dash, that is the 3 degree alcohol, correct? Students, one that is the from the synthesis of ketone is means that in the last previous lecture. So now we are going to complete here. This is that what it is a synthesis of ketone. Synthesis of ketone. So what synthesis of ketone is here? Here we'll take that RMGX, which will react with R dash C triple bond N, and the water is taken. So it will that will attack here. That R dash C triple double bond and MgX. Here is a negative charge also there. What is going to be happen, students? When we'll take that, will form that R dash C double bond R. So how it will form? We understand through the mechanism. When we'll take here, students, as you know, the nitrogen contains lone pair electrons also. So after moving these sides, there is a negative charge here. So lone pair react with the MgX, and then this compound is going to form here. When we'll take the water contains H or OH. So H, Mg, OH, that will remove, and what form? Mg, OH, X will form, and H will attack here. So that the going to form here RC double bond NH. Now again, when we'll take the water contains lone pair, so HOH. So again, what things will happen? That will attack here, and in that case, R dash C, okay, R dash C OH single bond NH2, and here is that R dash C NH, and okay. So now once it will remove, then the OH, here I write in detail. Okay, so what is going to form here? That is the OH, that will come here, and it will form that R dash C double bond O R. Now students, see that what happened? That the R dash, when it will react here, green alkyl group react will here, alkyl. This alkyl will react here, that will form here, and here is the alkyl group, correct now? So this alkyl group is there, correct? So here is the R, so that will form the ketone. Okay, student, one example I give you, can you write that answer? Just you check that. Here that MgI, okay, we react with that benzene C triple bond N. What do you think? What, just you think what product will form? Just pause the video, try to solve the question. What things will happen, students? Benzene C double bond O, and this is the cyclo compound will form, correct or not? Okay, so I hope all the things you understood. Students, once you understood, please like, share and subscribe the channel. Thank you. Have a nice day.